Hello there and welcome to A2 Maths. We're on Specimen Paper 1 and here we're looking at question 12 and integration questions. So, where do we start with this question here? Well, I can see that my answer is a ln something, and I've got a fraction inside my integral here, so immediately what swings into my brain is, can I use the ln rule? Well, to use the ln rule, if I differentiate the bottom, I get the top. If I differentiate the bottom, I get sine. It's not quite sine, it's sine 2 theta, which is not the same as just sine on its own. So we're probably going to have to use a different method. We've got 1 plus cos theta on the bottom, so what I suggest we probably do then is we use a substitution of u equals 1 plus cos theta. Now let's work out what our d theta is going to have to change into. Let's do du by d theta. So that's going to give us minus sine theta. So therefore, d theta is going to have to change into minus du over sine theta. So let's start now substituting things in. We could have a go at substituting our limits in now, but I'm not going to do it quite yet. I'll just remind myself that they are theta limits by writing theta equals 0 and theta equals pi by 2. Let's now start substituting in. Now remember, sine 2 theta is the same as 2 sine theta cos theta, and then this is going to be over u, and then after that we need to then multiply by minus du over sine theta. Now what's going to happen here is that the sine thetas are going to cancel each other out, and the only thing I've got left in terms of theta is my cos theta. But if I know that u equals 1 plus cos theta, then I know that u minus 1 is equal to cos theta on its own. In the next line, what I'll do in my integration by substitution is now substitute in the boundaries for theta equals 0 and theta equals pi over 2. So when theta is equal to pi over 2, what will u equal? Well, u will equal 1 plus cos of pi by 2. So grab the calculator, make sure it's in radians mode. 1 plus cos of pi by 2, and we get an answer of 1. And when theta is equal to 0, we get a u value of, well, put 0 into 1 plus cos of 0, and again using the calculator just to make sure we don't go wrong at any point, we get 2. Okay, so now our boundaries are going from 1 to 2. It looks a bit weird that it goes from 1 to 2. Looks like it's upside down because generally the higher number is on the top and the lower number is on the bottom. There's a way of sorting that out that I'll show you next, but don't worry about it for now. So moving on, I've got the 2 at the front here. I'm going to move that to the front of my integral as a scale factor multiplier. Cos theta, remember we're going to turn cos theta into u minus 1, so it's going to be u minus 1 over u minus du. That's not times minus, that's times minus du, it's not take away du, so it's just minus du here. Now, if you remember that what we're going to do eventually with these limits is we're going to substitute 1 in and then take away 2 substituted in. Well, what we could do is just reverse that order and make it substituting in 2 first and substituting in 1 in, but obviously the signs on those are going to be the wrong way round, so it's actually going to take out the negative symbol from the du part. So I can swap around my limits and at the same time take out a negative. If there wasn't a negative inside there, I would have to factorize out a negative to the front, but that's what you can do. Okay. You can take out a negative and swap the limits round, or you can swap the limits round and put a negative inside your integral if you want to, or just factorize it out to the front. So now all we're doing is we're integrating 2 from 2 to 1, u minus 1 over u. Let's now split this up into u over u minus 1 over u du. So this is going to simplify to 2 integral from 2 to 1 of 1 minus 1 over u du, and then this is going to turn into 2 times the integral of u minus ln u, from the boundary of 2 to 1. So now let's substitute in. It's going to be 2 multiplied by 2 minus, whoops, that's a u there, 2 minus ln 2 minus 1 minus ln 1. Remember, ln 1 is just 0, so it's going to be 2 minus 1, which is 1. Multiply that out and we get a 2, and then it's going to be take away ln 2. Ln 1 is just 0 anyway, so that will effectively just disappear, so it's take away 2 ln 2. So there we are, that's how we answer this 7-mark integration question there. So it was an integration by substitution question. And it had this pretty tricky little part of factorising out a negative and swapping around the boundaries. Now, you actually didn't need to do that stage. If you just carried on and worked it all through, you should still get this same answer as well. So you didn't need to do this step here. You could have still got the correct answer alternatively another way. And realise that when you've got u minus 1 over u, the way you can integrate that is just by splitting up the fractions, keeping the denominator the same on both the fractions, split up the numerator, and then you'll have 2 separate things to integrate. 1 just on its own integrates to u, and 1 over u integrates to ln u. And also as well, it was really important that we changed our limits into u limits instead of theta limits, because when we're integrating with respect to u, it's really important that our limits are in terms of u. And the way we can work that out is by using our substitution. Okay, so there we are. If you found that question pretty tricky, then maybe go back to the textbook and try some integration by substitution questions. Practice them until you become more familiar with them, and then maybe have a go at this question in a couple of days' time when you're feeling a little bit more confident about integration by substitution. It's a tricky topic and it does need a lot of practice. So there we are, that's question 12, that's 7 marks. Let's now move on to question 13.